In this video, we're going to derive the human capital earnings function. S is years of schooling. R is a rate of return from an additional year of schooling. Y subscript S is annual earnings with S years of schooling. So let's now get an expression for annual earnings with 1 year of schooling. So the Y subscript 1 is earnings with 1 year of schooling, and that's going to equal earnings without any schooling multiplied by 1 plus R, where R again is a rate of return from an additional year of schooling. Annual earnings with 2 years of schooling, it's going to look like this. So your annual earnings with 2 years of schooling will equal your annual earnings with 1 year of schooling multiplied by 1 plus R again. We're going to assume that the rate of return to schooling is the same for all years. So removing those subscripts on the R, we got two terms in parentheses here, so we can just put a squared on one of them. And the annual earnings with S years of schooling, going to look like this. And once again, assuming the rate of return to schooling is the same for all years, getting rid of the subscripts on R's. So we'll just simplify down to this. Now let's take the natural log of both sides of this equation. And on the right-hand side, we can simplify that a little bit. And one more simplification, taking this S here in the exponent and bringing it down in front. And then one thing to recognize is that for small values of R will approximate the natural log of 1 plus R. So if R equals 0.2, the natural log of 1 plus 0.2 is almost 0.2. And another example, when R is 0.1, the natural log of 1 plus 0.1 is, again, almost 0.1. And a few other examples here. So what we're going to do, we're going to substitute out this natural log 1 plus R and just replace it with R since they're close enough. And doing that, we're going to have S just multiplied by R now. If we take the total differential of both sides of the equation and dividing through by the change in S or ds, we see that R again represents the percentage change in earnings from a 1 unit change in schooling. So R gives a percentage change in earnings from an additional year of schooling. So just rewriting our equation and now writing the human capital earnings function in linear regression form, where A is the natural log of earnings without any schooling, and B is now replacing R. And B will be the coefficient that we'll estimate from a linear regression, once again representing the rate of return to an additional year of schooling. All right, that's it. I hope you found this video helpful.